This videotape discusses the idea of factoring polynomials. Our point of departure is once again the distributive law. You'll remember that A times B plus C is equal to AB plus AC. You've seen this many times. Now, when we're using the distributive law in this direction, okay, we're multiplying out. Okay, when we're using it in the reverse direction, when we start with something like this and we want to go back to this direction we call factoring. And that's what we're going to be concerned with today. Okay, let's start with a simple example. X squared plus 5x. Okay. We would like to write this as a product of factors. Now this is x times x plus 5 times x. In other words, it's in the form like AB plus AC. We see that both terms have x in common. We can factor out an x, and we'll be left with x plus 5. So x times x plus 5. Let's try this. X times x plus 5, multiplying it out using the distributive law, gives us x times x plus 5 times x, or x squared plus 5x. Okay, let's try a slightly more complicated problem. How about 6x squared y cubed take away 8xy squared? Okay, now in the problem above, it was fairly obvious what these two terms had in common. The most they had in common was x. Okay, here it's not quite so obvious. Okay, let's look at the constants. We have a 6 and we have an 8. The most that the 6 and the 8 have in common would be a 2. We can pull a 2 out, okay, from both of those. Then we look and we see that we have an x squared and an x to the first power. The most we could pull out in front would be an x. We have a y cubed and a y squared. The most that we could pull out, the most that is common to the two of them, is the y squared, 2xy squared. We can then write each of these terms as 2xy squared times something. Okay, the first one will be 2xy squared times something, and the second, 2xy squared times something. Okay, and we have to figure out what those somethings are. Okay, what would we have to multiply 2xy squared to get 6x squared y cubed? To go from 2 to 6, we would have to multiply by 3. To go from x to x squared, we'd have to multiply by x. To go from y squared to y cubed, we'd have to multiply by y. If you look over here, we do get 6x squared y cubed, which corresponds to the first term here. Now in the second term, we can also pull a 2xy squared out. Let's see what's left. To go from 2 to 8, to 2 to minus 8, you'd have to multiply by minus 4. To go from x to x, you just multiply by 1. And to go from y squared to y squared, once again, you multiply by 1. So if you take 2xy squared times minus 4, you get minus 8xy squared. Okay. Now, just like we did in the problem before, we will take this 2xy squared out in front. This will leave us with 3xy from the first term, take away 4 from the second term. Okay, notice this is just like the preceding problem. Here, the only thing they had in common was x. We took it out and we were left with, after we took out the x, we were left with x and 5. And here, after we take out the 2xy squared, we're left with the 3xy and the minus 4. Okay, now let's consider a slightly different problem. Instead of x squared plus 5x, let's look at x squared plus 5x plus 6. We would like to factor this. The first thing that occurs to us is that we do not have anything in common that we can pull out in front. These three terms, the x squared, the 5x, and 6, have no factors in common that we can take out in front using the distributive law. Okay, still we would like to factor this. We've seen expressions like this, trinomials, okay, polynomials with 3 terms, and we've seen them, and where did we see them? We saw them as answers to multiplying 2 binomials, okay, using the FOIL method. Okay, let's go back and review what we already know about multiplying two binomials. Okay, if we have something like x plus 4 times x plus 5, okay, we want to multiply this out. If you remember the FOIL method, first outer, inner, last, we take the first term in this parentheses by the first term in this one, first term in this polynomial by the first term here, giving us x times x, or x squared. The outer terms, x and 5, giving you 5x. The inner terms, 4 times x. And the last terms, 20. This is the first terms, outer terms. Here, however, the outer and inner give you 4x. Here you get minus 4x. These are the only possibilities over the integers that will give you the x squared and the 3, the first and the last. Neither one of them gives you the 5x that you need in the middle. Okay, so this is not factorable anymore over the integers. Okay, not factorable over the integers. These don't work. By the way, we started this videotape by looking for common factors. We would always, these problems, we're trying to concentrate on the idea of factoring these polynomials, but you should always be on the lookout for common factors when you start a problem. For example, if this first problem I had given you was, say, x cubed plus 5x squared plus 6x. The first thing you should notice is that you can pull an x out from all of these terms, leaving you with x times x squared plus 5x plus 6. Okay? And then you would proceed to factor the x squared plus 5x plus 6 the way we did over here, x plus 3 times x plus 2. Okay, so although I'm concentrating now on these second-degree trinomials, I really want you to be aware of the fact that we should always be checking to see if there's something that we can pull out in front first. First thing, when any factoring problem, first thing to do is to look for a common factor. Okay? If you don't have one, then you might proceed in some fashion like this. Okay, let's try some more problems. Now, all of the examples that we've considered so far ended up with a constant, okay? A positive constant. Let's try multiplying something like this, x plus 4 times x minus 5. Using the FOIL method, we get x squared minus 5x plus 4x minus 20. X squared minus 1x, or minus x minus 20. Whereas if you were to start with a problem like this, okay, we would like two numbers which multiply to minus 20. Okay? Multiply to minus 20 and add to minus 1. Now, if they're going to multiply to minus 20, it means they're going to have different signs. Okay, now when you add numbers with different signs, in effect, you're doing a subtraction. Okay, so bear that in mind in the problems that follow. Okay, let's try this. X squared minus 5x minus 6. Okay, notice now that this is ending with a minus 6, not a plus 6. Okay, we would like two numbers which multiply to minus 6 and add to minus 5. Okay, now it's possible you can do this in your head and you say x minus 6, x plus 1. This does it. It gives you x squared. The outer is 1x. The inner is minus 6x for the minus 5x. And the last gives you the minus 6. Okay, if you can't do it in your head, there's nothing wrong with listing all of the possibilities. Remember, when you're listing your possibilities, you're looking to make sure the first and the last match out. And then after you've listed all your possibilities, then you're going to work with the outer and the inner. Okay, I want, let's see, for my possibilities, I have to start with the x and the x, and I want the product to be, for the last terms to be minus 6. So I could have plus 6 and minus 1, minus 6 and plus 1, plus 3 and minus 2, and minus 3 and plus 2. The product has to be minus 6 now. All of the last terms here, of course, give you minus 6. All the first terms are x squared. Okay, and now we want, in this case, the sum of the numbers to be minus 5. Okay, here the outer gives you minus x, the inner 6x. That gives you 5x. In the third, you had minus 2x and 3x. That's 1x. Here, 2x and minus 3x. That's minus 1x. And this was the one that worked. The outer was 1x. The inner was minus 6x for the minus 5x. Okay, so algebraically, two numbers which multiplied, in other words, to the minus 6 and added to the minus 5, minus 6 and plus 1 will do it. Okay, some people just think in terms of, well, 6 and 1 or 3 and 2, and they say, well, there's going to be a subtraction involved in this one. In other words, it's going to be the 6 and the 1 factor because I want a subtraction and wind up with a 5. And then they worry about the signs afterwards. Whatever works for you. Remember, you can always fall back on listing everything. Okay, let's try some more problems. Okay, how about x squared plus 5x minus 6? Okay, the first and the last stayed the same. The only difference was the minus 5x in the middle changed to a plus 5x. Okay, when you see that, you know that there's not going to be too much change in the factors. Basically, what's going to happen is the signs are going to reverse on this. We still are dealing with, in other words, we want a 5 as a result of subtraction. And 6 and the 1 are basically the way to do it. Of course, it's going to be the plus 6 and the minus 1 here. The outer is minus x. The inner is 6x. That gives you the plus 5x now. The last terms give you the minus 6. Okay, let's try two more problems. X squared minus x minus 6. And also x squared plus x minus 6. You can shut off the videotape machine if you want to try these on your own. Okay, and come back to me after you've tried them. Okay, once again, we want the numbers to multiply to minus 6. But in the first instance, we want them to sum to minus 1. And in the last instance, we want them to sum to plus 1. Okay, let's see. It's going to be the 3 and the 2 that's going to do it for us this time because their difference, of course, is going to be the one that we need. In this case, we're going to use x minus 3 and x plus 2. The outer will be the 2x. The inner will be the minus 3x, giving us the minus x. And the last terms, of course, give you the minus 6, which is what we wanted. Okay, I saw that I wanted to get a negative result here. In other words, a minus 1. Okay, so I put the minus with the 3 here. So the minus 3x and the plus 2x, the minus would carry over. And over here, it's going to be x plus 3 times x minus 2, so that the plus sign carries over. Okay, still the 3 and the 2, but now it's minus 2x and plus 3x, giving you the plus 1x you need in the middle, and finishing up with the minus 6. Okay, now I want you to recognize two things. First of all, not all polynomials of this form. In this form, I mean something like, well, in general, we have something like ax squared plus bx plus c. These are the kind of polynomials we're trying to factor. Okay, this videotape, however, dealt exclusively with things that were in the form 1x squared plus bx plus c. In other words, where the lead coefficient was 1. It was 1x squared. Okay, first of all, not all of them factor over the integers. Okay, secondly, this is only good when the lead coefficient is 1. If the lead coefficient was not 1, okay, let's say the lead coefficient was a 10 or something else, then we'd have to consider ways to make the first term as well. See, here we only had to worry about the last terms. The first terms we knew were x and x. Okay, so in the videotape, which is going to follow this one, we're going to consider the more general problem, ax squared plus bx plus c, where we have to worry about ways to make the a as well as ways to make the c. Okay, and this is the end of this one.